Module 7 covers the potential spill control methods, proper personal protective equipment, and detection and monitoring devices for responding to ethanol blended fuel incidents.
Module 7, General Health and Safety Considerations. Specifically, we want to be able to help you to discuss the possible combinations of fuel and ethanol blended fuel spills and determine the tools, personnel, and steps necessary to clean up spills of various fuels. Understanding the properties and characteristics of both gasoline and ethanol will help emergency responders mitigate incidents involving ethanol blended fuels. Gasoline blended with up to 10% ethanol will retain hydrocarbon fuel chemical characteristics. Blends with greater than 10% ethanol will start to take on polar solvent characteristics. Absorbents and booms that are designed to pick up oil-type substances will pick up the ethanol blended fuel. When water is introduced to a gasoline-ethanol blend, phase separation may start to take place. Phase separation occurs after the fuel blend reaches the water's saturation point. The water will then attract the ethanol and form a water-ethanol solution in the bottom of the tank. In this situation, an oil-type boom or absorbent will pick up the remaining gasoline on top, leaving the water-ethanol solution. It is important to recognize the various types of spill control measures that may be needed in an emergency response. Different tactics will be needed for land spills versus water spills. It is also important to recognize what type of spill containment products will be needed. It is important to notify the appropriate local, state, and/or federal authorities having jurisdiction in the event of a spill. The water-ethanol solution can be picked up with water-absorbing boom or absorbent. Keep in mind that depending on the water-to-ethanol ratio, the solution may still be flammable. Also remember that if foam is used to contain the ethanol blended fuel vapor, a portion of the foam solution will absorb into the ethanol blended fuel, forming a solution that sinks below the gasoline level. This solution again will have water-ethanol properties, which will require a water-type boom or absorbent. The ethanol blended fuel located just below the foam membrane will require an oil-type absorbent, since the ethanol-gasoline blend will still maintain hydrocarbon characteristics. So our traditional methods of using just one absorbent type of material may not work in a case of an ethanol blended fuel spill.
Control zones are the areas established around a hazardous materials incident and indicate the safety level and degree of hazard in that particular zone. Control zones are initially established using the United States Department of Transportation Emergency Response Guidebook. There are 3 control zones that must be established: hot, warm, and cold. The hot zone is located immediately around the release of a material. This area encompasses materials that are hazards. It is the area of greatest danger and contamination. The warm zone is located immediately outside of the hot zone and is the area where decontamination takes place. The cold zone begins where the warm zone ends. The command post, as well as other support functions, is located in the cold zone. Personal protective clothing in this area may be limited to safety equipment and normal working clothes. After the control zones are established, then detection and monitoring is used to refine and enhance those control zones. Detection and identification of hazardous materials using monitoring equipment is normally performed by responders at the technician specialist level. Monitoring equipment is a crucial resource for responders to use in the incident assessment and during mitigation, especially involving ethanol blended fuels. Monitoring equipment will help responders determine the concentration levels of hazardous materials and make response decisions based on these readings. Utilizing a multi-gas meter can detect LEL, CO, H2S, and O2. Readings will help responders determine how best to protect themselves and others from the effects of the material and how far the public should be removed from the contaminated area. Ethanol, an ethanol-blended fuel, burns similarly to gasoline fires. Therefore, it is critical that all responders wear appropriate firefighter PPE. Protective clothing is designed to protect the wearer from head to toe and has proven to reduce the severity of injuries as well as save the lives of many firefighters. The following components constitute a general set of firefighter PPE: helmet with either a face shield or eye protection, protective hood, turnout coat, turnout pants, gloves, boots, and respiratory protection. Respiratory protection is especially critical since the respiratory system is the primary route of exposure into the body for hazardous chemicals. There are 3 types of respiratory protection: air purifying respirators, APRs, and powered air purifying respirators, PAPRs, supplied air respirators, SAR, and self-contained breathing apparatus, SCBA. Remember that all personnel responding to a spill or fire must wear and be trained in the use of the specific PPE required for a given emergency situation. See Figure 7.1 in the participant guide.
Non-firefighting personnel, if they're going to enter the hot zone, need to have fire-resistant protective clothing on. Regardless of whether you are confronted with a spill or a fire, there are certain procedures that must be followed in order to ensure safe incident management. Knowing the type of fuel that has spilled or is burning is essential to the success of your operation. In addition, you should take steps to contain the event and appropriately distribute the proper foam. It is very critical that all emergency responders wear appropriate PPE when responding to emergencies involving ethanol-blended fuels.